Alright, today we're going to talk about a plus b parentheses squared identities and minus identities. So we call this the square of a binomial. Let's go over this case of why this is true. So we're trying to find out what this equals, and it's actually not too hard to figure out what it equals because we can think of this geometrically. Now this is a, but we want to make a square of a and b, so let's do this. Now let's continue the square. Right, continue the lines across. Now let's just look at the pattern. I'm going to pretend like I've never seen this before and try to figure it out. Well, I have the region a squared. Sorry about that. Let me do this. I have the region a squared. This is a AB. And this is an AB, so like terms, I can make it 2AB. And then I have, this is a B, this area is B squared. So just looking at the diagram, I have this figure. Now let's look at the minus case. It's a little more tricky. Let's look at the minus case. So here's what I'm going to do. I'm going to start off this whole thing, let's call it A. This whole thing is A, and of course, this whole thing is A as well. Now, I want to subtract B. So let's do this. So let's call this side B. Now, if this whole side is A, and we just subtracted B, it follows that this side would have to be A minus B. So we're literally trying to find this area. And let's think of it a different way. Let's think of it as I'm first going to start off with my huge big square here. Sorry about that. So what is that? That's just, of course, a squared. Okay? Now, since this whole side is A and this is B, if I take away this, that's equal to AB. So I've taken away this region. Now, let me take off another AB, so two ABs. Now that's going to be this region right here. But notice how I counted this region twice. So when I take away my two rectangles, right, in order for me to be left with this quantity, which is what I want, I need to add b squared. Right? Double counted that region. So now that we intuitively understand it, we're just going to have to accept this and apply this rule to problems. So here's the way I recommend to do it. You need to know and have these, you should have it memorized, but always start by writing it out. So let's do a few positive examples. Alright, so this is the pattern we just found. Now let's do this. X plus 3 squared. Now I know many of you can probably do it in your head fast. Here's the way I recommend you set it up. Replace each letter with a parentheses. You want to really understand the structure when you're starting out. Now what's my A? This is my A. And this is my B. So we don't want A and B anymore. We want our new value, so let's just appropriately replace. So X, the pattern's always A, and then B, B. So let's use that pattern. It's just going to be X, X, 3, 3. And now let's continue it. So I have X squared. Multiplication is commutative, so 2 times 3 is 6, and then 3 times 3 is 9. Okay? Let's do this problem. X plus 5 squared. Again, let's take our time to set it up nicely. Right? Once you identify your A and your B, it's as easy as going A, B, B. So X, X, and then 5, 5. Okay? So let's continue it out. We have x squared plus 10x plus 25. Okay? Crooked. So once you get the structure, it's very easy. Let's do a few more. One more easy one. So take your time to, follow the format. I really recommend this when you're starting out because it really helps you see the structure. Now, this is my A, this is my B, so AABB pattern. So XX, and then 7, 7. So what does it become? X squared plus 14x plus 49. Alright, now let's do a couple of minus ones. X minus 8 squared. Well, this time I'm going to follow the same. I have to follow my A minus B squared formula now. So, this is my A, this is my B. It's simply AABB. So, XX 8, 8. Alright, so we get x squared minus 16x plus 64. Okay, one more minus one. X minus 9 squared. Well, take your time and then get the answer correct. So, we have XX 9, 9. So, x squared minus 18x plus 81. Let's do a couple harder ones, but let's see how the structure stays the same. Now, let's do this. 2x plus 3 squared. Nothing's changed. I'm still going to follow my format and my setup. See, now you'll really see the advantage of having this structure here because it really helps you out. Now, this is my A, this is my B, so it's going to be AABB. So instead, I have, careful now, it's 2x, and then 3, 3. So see how it just sets it up so nicely, and then 2x times 2x is, let's just be a little, I'm going to show my work here. 2x times 2x plus, so 3 times 2 is 24. Sorry, 12 when we're talking about. 3 times 2 is 4, yeah, 12x plus 9. So this shows why it's 4x squared plus 12x plus 9. See how easy that was once you set it up well? Let's do one more example like that. 5x plus 2 squared. So, first of all, fill out your format. Okay, now, this is my A, this is my B, so it's going to follow 5x, 5x, and then 2 and 2. So, 25x squared plus 20x plus 4. Okay, and let's do a couple minus ones. So, first things first, get the structure right. Okay, now, again, it's going to follow the AABB pattern. So 6x, 6x, 2, 2. So let the structure do the work for you. I really feel math is about structure and letting, make things easy on yourself. 36x squared minus 24x plus 4. So it's really easy once you get the pattern. Last thing I want to see, let's do one more of these. So 7x minus 3 squared. So parentheses squared minus 2. Okay, now this is my A, this is my B. So 7x, 7x, 3, 3. 7x, 7x. I'm just doing it color so you really see the structure, you know. So we have 49x squared minus 21 times 2 is 42x plus 9. Alright, last thing I want to say is that based on my experience, there's some people who still feel so comfortable looking at this geometrically that when they have a problem like this, they literally still look at it geometrically. So they do this. This is 5x. This is 5x. This is 3. This is 3. So that's okay to do that if you feel that comfortable, you know. With negatives, it'll work the same way. Just make it a negative. Now this is 25x squared. This is 3 times 5x is 15x. 3 times 5x is 15x. And then 3 times 3 is 9. So of course, filling in the picture, we have 25x squared plus 30x because we have two 15s, and then plus a 9. Okay? So how would it work with the negative? Well, you officially want to take away the area, but for the purposes of understanding it, it's okay to do this. It's going to be a little awkward because we're going to think of it as adding a negative 2. So let's do this. And just because it's a little bit harder to show subtraction, I'm just going to change it to an adding a negative. A bit awkward, but... So this is negative 2, negative 2. So this is 36x squared minus, so this is minus 12x, and this is of course negative 2 times negative 2 is 4. So it'll be 36x squared minus 24x plus 4. You know, you can't really have negative length, but it works to do it this way if you feel that comfortable by looking at the geometric model.